witnessed a total solar eclipse was in 2017, and its presence delighted enthusiastic skywatchers.
This is absolutely insane.
But what if, instead of a rare phenomena, a total solar eclipse became an everyday thing? Would you live in complete darkness? When does a total solar eclipse occur? And what would happen to the moon? This is What If, and here's what would happen if there were a permanent solar eclipse. A dragon devouring the sun, a giant puma demon, a pair of sky wolves. Throughout history and across cultures, an eclipse has been interpreted as a perplexing or fearful event. Even the 2017 total eclipse raised claims of impending apocalypse by evangelist groups in the United States. But what if the next eclipse didn't end? In this scenario, we're talking about a total solar eclipse, which only happens under very specific circumstances. First, it has to be a new moon phase. Second, the moon has to be at its closest position to Earth, also called perigee. And third, the moon has to be directly in front of the sun.
It's like a sunset all the way around me.
This rare planetary alignment would suddenly become a normal occurrence. But don't worry, you wouldn't live in the moon's shadow all the time. There are two parts to the moon's shadow. The umbra is the dark center, and the penumbra is the outside edge where only part of the sun is blocked by the moon. The umbra has a diameter of 267 kilometers, which is about the size of the state of West Virginia in the United States. Because of the Earth's axis, this large shadow would sweep across different parts of the globe during different seasons. The rest of the planet would be in the penumbra. You'd still get sunlight, just not as much as you used to, and life would certainly be a little dimmer. Existence on Earth is closely tied to the transition of day to night. A total solar eclipse would disrupt this pattern and wreak havoc on other natural cycles. Under the umbra, the temperature would drop about 5 degrees. Even minimal fluctuations have significant impact. Temperature changes and lack of sunshine are not great for agriculture, so we would have to get creative with growing our crops in this new cycle of light and dark. We would also see an increase in seasonal affective disorder, or SAD. This subtype of depression occurs during long winter months in high latitudes with lack of sunshine. You'd probably feel some of the same hopelessness and loss of energy under the moon's shadow. Though we'd have to come up with a new diagnosis, maybe eclipse affective disorder. In a typical total solar eclipse, the umbra moves across the globe from west to east, lasting only about 7.5 minutes. This is because the moon rotates around the Earth, making a static eclipse impossible. So the only way we could see a permanent solar eclipse is if the moon stopped rotating around the Earth. Without its own trajectory, the moon wouldn't be able to resist the gravitational pull from Earth and would eventually destroy us. If that were the case, then a total eclipse really would be a doomsday warning. Observing a total solar eclipse is a once-in-a-lifetime opportunity. Let's hope it stays the marvel it is. Life on Earth relies on the predictable pattern of the sun and the moon, and we would be in big trouble if our orderly cosmos changed. It's almost as old as the universe, and as massive as 34 billion suns. It eats stars for breakfast. And now it's about to consume ours. behold, the great and powerful black hole with the catchy name J2157. If it came close enough to our solar system, how fast would it destroy us? How would it all go sideways for our sun? And how exactly would this monstrous black hole end all life on Earth? This is What If, and here's what would happen if a black hole swallowed the sun. Black holes are scary enough. They form when big stars explode in a supernova and then collapse in on themselves. The most common black holes, the stellar ones, are only 16 kilometers in diameter, but they have the mass of a star at least 10 times more massive than our sun crammed in them. All that mass compressed into such a small diameter makes black holes extremely dense. If you came too close to a black hole's vicinity, beyond its event horizon, its extreme gravitational pull would turn you into a spaghetti noodle. But there are black holes so massive that they make stellar black holes look feather light. These are called supermassive black holes. These monstrosities lurk at the centers of galaxies and take up space roughly the size of our solar system. But most of them don't even get close to the size of black hole J2157. J2157 is the fastest growing black hole in the known universe, and it's the second largest one. Its event horizon has a radius of 670 astronomical units, which is comparable to the distance between the Sun and Neptune multiplied by 22. Whoa! If that's not scary enough, J2157 holds the title of the hungriest black hole we know. To stay in good shape, it gobbles up matter at a rate of about 1 sun per day. Now, take this monstrosity and bring it closer to our solar system. You can imagine how that would play out. If J2157 could replace the supermassive black hole that sits at the center of our Milky Way galaxy, to us on Earth, it would look 10 times brighter than the full moon. That's because of its incredibly large accretion disk, the matter the black hole collected on its way to us. And because it always needs to be the center of attention. This monstrous black hole would outshine most of the stars in the sky. If a black hole under 100 million masses of our sun entered our solar system, it wouldn't swallow the sun in one go. It would gradually start pulling matter from our star until all that's left of it would be a cloud of gas. In that case, you could expect lethal amounts of cosmic radiation headed toward the Earth. But that's not how J2157 likes to deal with things. A black hole of that size and mass would devour the sun in a moment. But losing the sun would be the least of our problems. Our planet could be torn apart by the tidal forces from the black hole consuming our sun. Or it could be bombarded with an unthinkable amount of cosmic radiation. Or it would disappear into the black hole's event horizon, along with the rest of the solar system. Either way, you wouldn't get out of this alive. But no matter how big and scary J2157 is, remember that it sits at a safe distance of 12.5 billion light years away from us. I'd say we're pretty safe here. Humanity's nuclear arsenal is capable of destroying all life on Earth over and over
and over. Maybe it's time we dumped it far away. Now, we might want to inhabit other planets in the future, so how about our closest star? How many nukes could we throw at the sun? What would be the price tag for this mission? And could we accidentally destroy our only source of daylight? This is What If, and here's what would happen if we nuked the sun. The sun is mainly made of hydrogen and helium. The temperatures and pressures at its center are extremely high. So high that the hydrogen atoms fuse together and become helium. That process releases enormous amounts of energy that powers the sun. It's known as fusion. And you know what else uses fusion to power up? Yeah, that's right. Most modern nuclear weapons get their destructive energy from fusing hydrogen isotopes. This is why they're often called hydrogen bombs or fusion bombs. Around 5 billion years from now, the sun will run out of hydrogen and die. A dead sun is terrible news for Earth because we will die along with the star. Now, if humans managed to stick around for that long, we would be scrambling for ways to keep the sun fueled and running. And if we were also still interested in getting rid of our destructive hydrogen fusion bombs, could we nuke the sun and power it back to life? Well, first things first, we would need to gather each and every single nuke on the planet. This wouldn't be easy since the 9 countries that are known to possess nukes are extremely suspicious of each other. But if the other option is the guaranteed death of our only sun, they could be willing to give up their weapons of mass destruction for the cause.
Take my gun from me.
How big is humanity's arsenal, you might ask? Well, at least 13,000 nuclear bombs big. Each of them with the explosive power of at least 100 kilotons of dynamite. The United States alone is estimated to have 650 bombs that are 60 times more powerful than the nuclear bomb dropped on Nagasaki during World War II. If you were overseeing this explosive operation, you would need to be extremely careful. After all, you definitely wouldn't want to have a surprise detonation. If every one of these fusion bombs went off, the explosion would lead to so much debris being injected into the atmosphere that it would trigger a nuclear winter. That's because sunlight would be unable to reach the Earth's surface. Cue the worldwide below freezing temperatures, ecosystems collapsing, and nuclear fallout. This accident would devastate all living beings, humans and animals alike. In trying to save the sun, humanity could block itself from all of its warm rays. Ironic, isn't it? So yeah, you'd need to handle with care. You'd also have to sharpen your fundraising skills. If a modern nuke has a mass close to the one dropped on Nagasaki, sending it to space would cost around $170 billion. And that's just for one bomb out of the 13,000. It's fair to say the whole world economy would need to bend and break in order to subsidize the survival of the sun. And humanity. Even if you did come up with the cash, there are far hotter challenges ahead. Like, how do you build a spaceship that doesn't melt as it approaches the sun? The closest a spacecraft has come to our star is 8.5 million kilometers. Even at that distance, it still had to endure temperatures of 1,377 degrees Celsius. Only thanks to a thermal shield made up of carbon composite material was it able to withstand the scorching heat. However we send our hydrogen bombs into space, it will have to incorporate a much improved version of this protection system. So add that to the bill. And there would still be a mountain of remaining technical obstacles, like finding the safest location to launch the nukes into space, or developing the technology that will allow us to monitor and control them from such a massive distance. But let's say you manage to do it. All our nukes are in orbit and within launching distance to the sun. This is it. You send the order to fire all the hydrogen bombs into our hydrogen-fueled star. Now, you wait to see how it begins to recharge. Just a little longer. Little longer. And nothing seems to happen. The anchor of our solar system continues to die. But how? Well, as colossal as the power of our 13,000 nukes might seem, this punch is nothing compared to what the sun is packing. Right now, our star emits over 70 million times more energy per second than all of our nuclear weapons combined. Even if it were running out of hydrogen to fuse into helium, throwing our hydrogen bombs at it to feed it would be like throwing a box of matches into a forest fire. You'd barely make a dent in the blaze. Yeah, that's a bummer, but at least you didn't destroy what little remains of our decaying sun. If that was your intent, you'd need something with a lot more firepower. Meet the antimatter bomb. When the Big Bang created the universe, it did so with an equal amount of matter and antimatter. Matter is what you, the Earth, the Sun, and most things are made of. Antimatter, on the other hand, is composed of subatomic particles with properties opposite to those of normal matter. Put a little simpler, it's the inverse of matter. When a particle of matter collides with an antiparticle of antimatter, they annihilate each other in a flash of energy. If enough of those two camps came in contact with each other, it would lead to a massive explosion, also known as an antimatter bomb. But here's the catch. Antimatter is incredibly rare. If you pooled together all the antimatter on the planet, you'd end up with only around 20 nanograms. A single nanogram is only 1/1000th of a gram. That is so little that even if it were combined with matter, you wouldn't even have enough energy to boil a cup of tea. Now, you could produce more antimatter, but that would cost you at least $2.7 quadrillion for just 1 gram. And remember, we're here to save the sun, not destroy it.
In 5 billion years, we're going to have a hefty problem on our hands. Well, only if we're still living on Earth at this point. Our sun will be on the brink of collapse. If we don't find a way to give it all the fuel it needs, well, we're toast. How could Jupiter help us refuel the sun? What other stars have consumed gas giants? And what would life be like without Jupiter? This is What If, and here's what would happen if we refueled the sun with Jupiter. The sun's delicate balance of hydrogen and helium keeps us alive and well. Although you might think there's an infinite ball of energy up there, I hate to break it to you, but the sun's not sticking around forever. In order to keep it going, our sun needs a consistent source of hydrogen. At its core, the sun's hydrogen is converted to helium in the process of nuclear fusion. This fusion reaction is exothermic, meaning it gives off more energy than it consumes. This energy is released as gamma radiation, which provides enough of an outward push of gravity to keep the sun from imploding. So, how exactly can Jupiter help with all this? Well, about 90% of Jupiter's atmosphere is made of hydrogen. This makes it one big ball of fuel, even though it's only 0.01% the mass of the Sun. Astronomers have located a sun similar to ours that has been eating a Jupiter-like gas giant called WASP-12b. Good one, science. I hate wasps too. WASP-12b's atmosphere is being sucked up by its star, forming a hot ring of gas around it. As its atmosphere is pulled outward, this is making the planet puff up to 6 times the size of Jupiter. Our Sun gobbles up hydrogen at a rate of 620 million metric tons per second. With 4 gas giants in our solar system, we could keep the Sun sizzling for another 87 million years. With Jupiter being the biggest, we'd probably want to start there. In order to pull this off, we'd need to set up Jupiter like WASP-12b, close enough to the Sun to deliver a constant influx of hydrogen from its atmosphere. It would have to be just enough hydrogen so that no mass is added or lost from the Sun. In other words, like a healthy diet and exercise with an occasional cheat day. But couldn't we just smash Jupiter into the Sun? That sounds like more fun to me. Well, this would make for some good fireworks, but this would increase the Sun's mass too quickly, causing it to burn hot enough to turn global warming into global roasting. The key is to keep the Sun's mass stable, so its fusion remains consistent at its core. Even if we managed to nudge Jupiter close enough to the Sun, that could lead to a whole slew of other problems. Because without Jupiter's stable gravitational pull, all of our planetary orbits, including Earth's, would be thrown off course. And we'd lose our precious shield against deadly asteroids and comets. So, realistically, we'd probably have to suck it up and move somewhere else. Who knows? Maybe there's a really nice Earth-like exoplanet out there for us to settle.
Billions of years in the future, the Sun will begin to die. And this is what our planet would look like. But what if we turn things up a notch or two? Let's upgrade our star from yellow to blue. How different would the world look? Could your body handle the increased heat? Or would all life on Earth die? This is What If. And here's what would happen if the Sun was a blue star. Like any visible light, sunlight contains all the colors of the rainbow. But how we see a star, or any planet, depends on how hot the star is. The coolest stars in the universe have temperatures of about 1750 degrees and emit more red light, while the hottest stars have temperatures over 40,000 degrees and look bluer. Our Sun has a surface temperature of 6,000 degrees, so it emits almost equal amounts of blue and red wavelengths. If you could see the Sun from space, it would appear whitish. Hang on a second, the Sun isn't yellow? Yeah, that's right. The Sun only appears yellow to you because of Earth's nitrogen-rich atmosphere. Red light and yellow light have longer wavelengths and can reach your eyes easier. Blue light has a shorter wavelength and scatters more, giving the sky its blue color. But if our Sun was a blue star, you'd never get to see a spectacular orange sunset again. Oh, and also you'd get fried instantly. Now, before making our sun blue, let's take a look at a couple of bright blue stars that we know of. On the cooler end of the blue star spectrum is Rigel, the brightest in the Orion constellation. Its surface temperature is about 11,000 degrees. While it's almost twice as hot as our sun, Rigel emits at least 40,000 times more energy. And Rigel's diameter is 79 times larger than our star. If our sun was that large, it would swallow Mercury, and temperatures on Earth would increase immensely. But why stop there? You could turn the dial up even further. If we imagine our sun on the higher end of the blue star spectrum, it could be like Eta Carinae. With surface temperatures of 40,000 degrees, this star is over 6 times hotter than the sun. But what's staggering is that Eta Carinae emits 1 million times more energy than our sun. If our sun was that hot, it would be 5 million times brighter than it is today. Violent ejections of plasma would scorch our planet regularly. And the sun would drench us in lethal amounts of UV radiation. There's no way you could survive the heat. If you stepped outside for just 1 second, it would be like stepping in an oven, only hotter. The blue sun would instantly burn all the tissues in your body to ashes and maybe even your bones. It would be game over for you. Just kidding, I wouldn't let you off the hook so easily. Okay, let's imagine that your body was super resistant to this extreme heat. There would still be that enormous amount of UV radiation to deal with. And it would wreak all kinds of havoc on your body, causing your skin to wrinkle, age, and get cancer. Your vision would suffer immensely too. You'd get something like a sunburn in your eyes. The UV radiation would make your vision blurry and your eyes would hurt like hell. It would be like snow blindness, except caused by the sun's radiation. In addition to losing your sight, the blue light would mess with your beauty sleep. Blue light suppresses your melatonin levels. With so much more blue light and so much less of this hormone, sleeping would be tough. Poor sleep could lead to high blood pressure, diabetes, and even heart failure. The blue light would affect a lot more than just us humans. Outdoor plants would grow smaller, thicker, and have darker leaves. High-intensity blue light would promote flowering in long-day plants that usually need at least 12 hours of sunshine a day to thrive. All the other plants that don't like as much sunlight would die. Well, you'd still likely have long-day garden vegetables like lettuce, spinach, and potatoes. But if our sun became as massive as Eta Carinae, you'd have heavier problems than what to eat in your new diet. The sun's new, incredibly intense gravitational pull would disrupt the solar system. Yeah, you'd see Earth and all the other planets get swallowed up by it. Instead of getting engulfed by this massive sun, you'd be lucky if Earth went a little sideways and got shot off into space. Then, we'd live on a rogue planet that's not held by a star's gravity and roaming in the universe. But we'd likely freeze up pretty quickly and die anyway. If there's one benefit, it's that all this chaos and destruction wouldn't last forever. Instead, it would end quite quickly. A star like Eta Carinae has a live fast, die young lifestyle. At its young age of about 3 million years, it's already nearing the end of its fuel supply. It could explode into a supernova sometime within the next 100,000 years. Our sun is about 4.5 billion years old, and scientists expect it to keep burning for another 7 billion years. So if we turned up the sun's heat, we'd be dooming our star and our planet to premature death. Not that many life forms would survive to see that day. The earliest life on our planet dates back to about 3.7 billion years ago. At that point, our sun was already 800 million years old. Back then, if the sun burned as hot and bright as Eta Carinae, it would have exploded as a supernova hundreds of millions of years before there was life anywhere nearby. So, our lives seem better with the sun burning at its current temperature. Ah, the sun! So bright, so hot! Time to jump into your super heat-resistant spaceship and get so close you could touch it. If you dare. How would you get to the sun's surface? What kind of temperatures would you encounter? And what kind of materials could even protect you from this scorching heat? This is What If, and here's what would happen if you touched the sun. Yow! The sun is so massive that it accounts for 99.8% of our solar system's total mass. With a diameter of 1.4 million kilometers, you could fit about 1 million Earths inside of it. It burns bright due to the process of nuclear fusion. Hydrogen atoms fuse to create helium, and it's worked that way for 4.5 billion years. It'll be another 5 billion years before it burns through all of its hydrogen. Then it will burn helium and will start to swell. Eventually, it will swallow Mercury, Venus, and the Earth. So you better touch it before it touches you. Okay, it's time to head off on your journey to the sun. Considering that big ball of gas has such a massive gravitational pull, it should be a pretty easy flight, right? Well, this journey is going to be more of an odyssey. That's because Earth is traveling almost entirely sideways relative to the sun, at a speed of about 108,000 kilometers per hour. To get to the sun, you'd need to cancel out that sideways motion. And that would require a lot of energy. About 55 times more energy than it takes to travel to Mars. Like the Parker Solar Probe, your Uber ship is capable of speeds reaching 163 kilometers per second. But you're still going to have plenty of time to prepare on the way. After 3 years, you'd arrive at the sun's outermost layer, the corona. This layer is located 7 to 10 million kilometers above the sun's surface. And big surprise, it's hot. About 1 million degrees Celsius. And that's about 900 times hotter than lava. At this point, you'd also be exposed to massive amounts of radiation. Make sure you slather on copious amounts of specially formulated sunscreen that could shield you from everything from ultraviolet light to gamma rays. Without this, you could get radiation sickness, leading to cancer, then death. Not the most ideal kind of sunbathing, right? Obviously, you should wear sunglasses too, or better yet, have a sun shield in your heat-resistant spacesuit. The sun would be tens of thousands of times brighter here than it was back on Earth. Traveling onward, you'd reach the chromosphere. Now, you're 3,000 kilometers above the sun's surface. And surprisingly, temperatures here would take a big drop. In the chromosphere, they'd range from 3,700 to 7,700 degrees Celsius. And unlike other layers, it would get cooler as you get closer to the sun. But look out! Massive loops of plasma could jet out toward you. These are solar prominences, and they are extremely hot. Plus, they could be 10 times the diameter of Earth. You'd now see how granulated the surface of the sun looks up close. Below you would be bright expanses as wide as Texas, surrounded by narrow, darker regions. Next stop, the photosphere. You'd have finally arrived at the surface of the sun. As much as you'd like to land here, you couldn't. That's because the sun has no actual surface. It would be like stepping out onto a cloud, a scorching, searing cloud. The gravity would be so intense that if you weighed 70 kilograms back on Earth, you'd now weigh a whopping 1,800 kilograms. Outside of your ship, that extra weight would crush your bones and organs. Okay, pushing deeper from here, you'd enter the convective zone. Temperatures would now hit 2 million degrees Celsius. That would be almost 400 times hotter than Earth's core. The density here would be so intense, even light would have a hard time escaping. A little bit like in a black hole. You'd be cooking in a soup of densely packed solar particles, blinded by their luminosity. Finally, you'd make it to the core, 500,000 kilometers below the surface. This is where the sun's nuclear fusion occurs. Okay, so what would happen now if you reached out and tried to touch the sun? This would be light years beyond sizzling. You'd be almost instantly obliterated. A cremation furnace has temperatures of 1,000 degrees Celsius. That wouldn't even compare to the millions of degrees you'd encounter down here. And sorry to say, there's no material on Earth that could withstand these temperatures long enough for you to find out what the sun really feels like. The closest we could get right now is about 1.6 million kilometers away. Probably should have mentioned that at the start.
There are sunsets on other planets even more spectacular than the ones on Earth. What if we could see not just one, but 2 suns falling below the Earth's horizon? Would our planet get much warmer with 2 stars heating it up? Would we ever experience nighttime again? And could our binary star system be able to sustain life? This is What If, and here's what would happen if we had 2 suns. Not all star systems form around a single star. Some scientists even suggest that our sun once had a star companion, a long-lost dwarf star called Nemesis. It broke free of the sun's gravity and melted into the Milky Way billions of years ago. Our search for Earth-sized planets throughout the galaxy showed us that not only are most star systems binary, but they also have habitable zones and planets within them. It looks like the Earth could sustain life with 2 suns instead of just 1, but only under certain conditions. In a binary star system, Earth's fate would depend on many factors, from the masses of the stars to their position relative to Earth and each other. Chances are high that Earth's orbit would be very unstable. If one of the suns was bigger and brighter and had a much stronger gravitational impact on us, that sun could pull the planet towards itself. We'd get pretty crispy before disappearing in its solar flares. On the other hand, if neither star's gravitational pull was strong enough, the Earth would fly out into space. We'd become one of those rogue planets that travel the universe all alone with no star system to call home. Let's assume that the Earth's orbit would be stable. This would be possible if the Earth orbited just one of the suns. But that's no good for complex life on the planet, because at some point the stars would face both sides of the planet at the same time. Not only would that take away our nights, but it would also bring double doses of UV radiation and solar winds. No sunscreen could prevent you from getting toasted by 2 suns. The Earth's orbit could be stable if the planet rotated around the two stars. The stars would have to be close together, and the Earth's orbit would be further away. Just how far away? Most likely beyond the habitable zone, where the heat of the suns wouldn't be enough to keep our water in a liquid state. The planet would turn into a frozen, lifeless rock. Feeling hopeless yet? Well, we have some good news for you. The best case scenario for our planet would be if we replaced our sun with two closely matched stars, each half as bright as the sun. This would keep our planet warm enough to sustain life. Because the total gravity of the two stars would be stronger, it would take the Earth 280 days instead of 365 to make a whole circle around them. The distance between the stars would have to be less than 15 million kilometers apart. That way, the orbits of all the other planets in our system would be stable, even Mercury's. But let's play safe and assume the distance between the stars was about 5 million kilometers. In that scenario, the two stars would orbit each other once every 10 days. Every 5 days, one star would pass in front of another. From Earth, that would look like a solar eclipse. But instead of our moon blocking the sun, it would be one star blocking another. And instead of 7.5 minutes, that eclipse would last for about 5 hours. Under those conditions, the Earth could be just fine orbiting two suns. The only question is whether the Earth would have formed in a binary star system in the first place. What if, instead of shining brightly for another 5 billion years, the only star in our solar system turned into a dark and cold remnant, a black dwarf? How long would the Earth last without all the heat and light it gets from the sun? And how would the sun going dark change the universe? This is What If, and here's what would happen if our sun turned into a black dwarf. All stars have an expiration date. They don't just fade to black though. Stars like our sun don't have enough mass to become a neutron star. They end up expanding to red giants and then shedding their outer layers until only their core remains. That's when they become white dwarfs. White dwarfs don't have fusion reactions fueling them up. They gradually cool down until one day they become black dwarfs. The thing is, there are no black dwarfs anywhere in the universe. Black dwarfs just haven't formed yet. You see, white dwarfs may not produce any energy, but they still have enough of it left to keep them shining, faintly, for hundreds of billions of years. Given that the universe is only 13.8 billion years old, even the oldest white dwarfs are still glowing at temperatures of a few thousand degrees Kelvin. In the case of our sun, it will take another quadrillion years for it to cool down and become a black dwarf. That's 1 million years from now, give or take a few millions. Think humans will be around for that long? Well, let's switch it up. What if the sun burnt out tomorrow? I hope you have a good supply of batteries on hand because the entire solar system would be thrown into darkness. Put on a few sweaters because it would become much colder too. Planetarily speaking, we're pretty spoiled here on Earth. With all the heat and light provided by the sun, we're able to make a comfortable home on a rock hurtling through space at 110,000 kilometers per hour. It's easy to forget that we're just another speck in the universe. But if the sun stopped burning, it would be immediately evident that we're just floating in space. After the first week without the sun's heat, the Earth's surface temperature would drop to 0 degrees Celsius. After a year, it would go down even more, dropping to a freezing cold -100. That is, if the sun turned into a black dwarf instantly, which is unlikely, even for our hypothetical scenario. Realistically, to become a black dwarf, the sun would have to go through all stages of the stellar life cycle. From the main sequence star it is now, the sun would expand into a red giant, fade out to a white dwarf state, and only then cool down to become a black dwarf. At the red giant stage, it would bake the Earth, most likely swallowing it completely along with Venus and Mercury. At least we wouldn't have to worry about freezing to death once the sun shrank to a black dwarf. What about the rest of the planets, the ones lucky enough to have evaded the burning flames of the red giant? Well, they'd keep orbiting that remnant of the sun as if nothing had happened. Even though the sun would shrink to the size of the Earth, its mass would stay the same, meaning that its gravitational pull would remain unchanged. In the grand scale of the universe, the death of the sun wouldn't change anything either. The sun would be just another star to go dark, too small and insignificant to make the universe even a tiny bit darker. What if the sun disappeared right now? Would you be able to handle eternal darkness? Cold temperatures? How about flying off into space? The sun is the only star in our solar system, and it gives life to everything here on Earth. Would we even be alive if it vanished? This is What If, and here's what would happen if the sun disappeared. The truth is, we wouldn't even notice for the first 8.5 minutes. This is how long it takes sunlight to travel to our planet. So even if the sun disappeared, its last ray of light would take 510 seconds to reach your skin. And what about gravity? The sun is the dominant gravitational force in our solar system. It has all 8 planets moving around it. So if the sun disappeared, would we fly off into space? Yes, but not right away. The force of gravity turns out to have speed too. In his theory of general relativity, Einstein proved that gravity is just as fast as light, and not instantaneous as was previously thought. This means the Earth would still be orbiting a recently vanished star with no clue of the upcoming darkness. But just for 8.5 minutes. When the last of the sun's rays reached the Earth, eternal night wouldn't be our only problem. The very same moment the sun disappeared from the sky, Earth would start traveling into space at 18 miles per second. Assuming the Earth didn't collide with any other planets or asteroids or get sucked into a black hole, it would be moving in a straight line for 43,000 years before it found another star to orbit. But you wouldn't have to worry about that. Within 2 seconds, the moon would go dark, since there would be no sunlight to reflect. But the stars would still shine, and your electricity would still work, unless it's powered by solar panels. However, gravity and illumination aren't the only things we rely on the sun for. Plants need the sun for photosynthesis. Turning light into energy is how plants stay alive. Without sunlight, most small plants would be dead within days. Larger ones, like trees, would survive for several decades due to their slow metabolism. This would knock out the bottom tier of the food chain. Most animals would die off slowly. Only scavengers feeding on the dead would remain until they froze to death. Because within a week, the average temperature on Earth would drop to a bone-chilling 32 degrees Fahrenheit. And by the end of the first year, minus 150 degrees would be the new norm. And it would keep dropping until stabilizing at minus 400 degrees Fahrenheit. The oceans would grow colder too, but just on the surface. Thanks to geothermal vents, they would remain liquid underneath, despite being buried under a thick layer of ice. So if you're lucky enough to survive, consider moving to the ocean floor. In the end, the organisms living around those geothermal vents would be the only living beings not to notice any difference. They don't need the sun to live and could continue to thrive for billions of years until the planet became a frozen chunk of rock drifting in space.
Every year, our planet makes one full trip around the sun, and while that means we're already moving at breakneck speeds, we're about to ramp that speed up. Like, way up. Let's turn the Earth into a planet-sized spaceship and crank it up to light speed. Why would this make Earth extremely heavy? What would happen to Earth if it started orbiting so fast? And what would it be like to experience all this from down on the ground? This is What If, and here's what would happen if the Earth orbited the sun at the speed of light. Okay, nothing travels faster than light, so brace yourself because light moves through space at a blistering 300,000 kilometers per second. That means from the moment a particle of light leaves the sun, hurtling directly toward you on Earth, it takes just 8 minutes before it hits you in the face. Or gently caresses your face. Yeah, it only takes light 8 minutes to travel 150 million kilometers. And light reflecting off the moon only needs 1 second to reach your eyes. Now, when it comes to an object cranking up to the speed of light, things aren't just as simple as picking up the pace. Let's take our planet. As it gets closer to the speed of light, its mass increases until it becomes infinite. And to move an infinitely massive object, you're gonna need an infinite amount of energy. And that's just impossible. Until now. Earth already orbits the Sun at 30 kilometers per second. And while that's not slow at all, compare it to the speed of light and that's not even a drop in the bucket. If you want to be more precise, Earth orbits this big scorching ball at only 0.01% of the speed of light. So we've got a lot of ground to cover here. But don't get ahead of yourself, because even if we just increased Earth's orbital velocity to 42 kilometers per second, we'd be in serious danger. That's because at this speed, Earth would achieve its orbital escape velocity. That means it would be traveling fast enough to escape the Sun's gravitational pull. We'd just be traveling out into space. Another cold, rogue planet with no star system to call home. Of course, we'd cross the solar system before being ejected out of it for good. After about 3 years of moving at this speed, Earth would reach Neptune. At that point, we'd have already passed all the other planets in the outer solar system. If we got really unlucky, Earth might crash into the big ball of gas, Jupiter, along the way. Now, for a moment, that would be a pretty view as we approached, but what a shame it wouldn't last long enough for you to enjoy, because Earth colliding with Jupiter would have some lethal side effects. But we wouldn't let your epic journey end so abruptly. In this scenario, Earth would keep hurtling through the solar system and beyond. We'd keep speeding further and further out of our planetary hometown and into the big unknown. And without the Sun's heat, well, Earth would slowly but surely become a cold and lifeless rock. Okay, well, that didn't go as planned at all, so how about we start over? Let's break the laws of physics and keep our planet in the Sun's orbit as it reaches light speed. What would that be like? Well, to accelerate the entire planet to such an incredible speed, we'd need a lot of energy. How much? Well, more than you could imagine. Even if you wanted to accelerate yourself to only about 90% of the speed of light, well, you'd need as much energy as the entire world consumes in 5 days. So, where in the universe would we manage to get enough energy to speed the whole planet up? Well, your best bet would be to follow the lead of a very rare but extremely fast kind of star. A hypervelocity star. These are stars that can reach speeds of up to 33% of the speed of light. There may be as few as 1,000 of these kinds of stars in our entire galaxy. All because they need a unique chain of events to unfold first. Hypervelocity stars reach their hyperspeeds by orbiting a black hole that's colliding with another black hole. These two black holes begin a kind of dance with each other, spinning faster and faster until eventually they let go. And that gravitational disruption leads to the stars being ejected across the universe at these insane speeds. Alright, so it's simple. In order for us to reach the speed of light, we just need to swing around a black hole or two. What's the worst that could happen there? Now, experiencing light speed on Earth wouldn't be exactly like what you see in the movies, when the Millennium Falcon or the USS Enterprise engage thrusters. For starters, you wouldn't see any more stars in the night sky. That's because you'd be experiencing what's known as the Doppler effect. In scientific terms, all the light traveling toward Earth would now have a higher frequency, moving from the visible spectrum into the X-ray range. To put it simply, the light from the stars would become invisible to you because the human eye can't see X-rays. And it could mean invisible danger for you. X-rays can cause many health problems and increase your risk of cancer. While today's atmosphere is thick enough to prevent most of this radiation from stars reaching us, traveling at the speed of light might put our atmosphere to the test. Yeah, we could lose our protective air shield, which also means, on this Earth, that you wouldn't be able to breathe. A rogue star is headed straight for our sun. If these two stars slam into each other, it could spell the end of all life on our planet. How could a rogue star end up in our solar system? What would this epic collision look like? And how much time do you have to live? This is What If, and here's what would happen if a rogue star collided with the sun. As the name would suggest, rogue stars drift through space. They don't belong to any particular galaxy, or if they once did, they've been ejected from their homes at some point by supernovas or two galaxies ramming into each other. Whatever it is that sends these stars hurtling away from the gravitational pull of their original galaxies, it fires them off at very high speeds. In order to break free of our own Milky Way galaxy, a star would need to move as fast as 550 kilometers per second. Luckily, our sun is only moving at a mere 200 kilometers per second, not nearly fast enough to become rogue. But these wandering stars aren't all that uncommon. They may even account for as many as half of the 200 billion trillion stars in the universe. And one of them could be headed toward our sun right now. Meet Gliese 710. This rogue dwarf star is on a trajectory that would bring it close to our solar system in around 1.3 million years. When Gliese 710 eventually reaches us, it would enter the outermost section of our solar system, the Oort cloud, at a speed of about 51,500 kilometers per hour. It could send the icy bodies out there flying in different directions, maybe even right toward Earth. Once it has reached Neptune, the countdown to the epic collision would begin. T-minus 10 years till the impact with the sun. At this point, you'd better just plan to live your best life while preparing for the upcoming apocalypse. The gravitational pull of Gliese 710 would destabilize the orbits of our planetary neighbors, nudging them left and right. This could go as far as pushing Earth out of the habitable zone. Or it could turn us into a rogue planet after unceremoniously being catapulted out of the solar system. After 10 years, it would finally be getting close to collision time. As each day passes, things are only going to get worse. One possibility is that the Sun and Gliese 710 would merge into a red nova. This would result in a violent explosion that would unleash nearly 500,000 times more light than what the Sun does right now. Given the amount of time light takes to travel from the Sun to the Earth, you would be blissfully unaware of this destructive explosion for 8 minutes. But the moment you do find out, all that light would likely blind you in a millisecond and then immediately fry you on the spot. That's because directly behind this blinding light would be super hot gas. This wave of heat could be powerful enough to wipe out nearly everything in its path. Bye-bye Mercury, Venus, and yeah, Earth too. Our atmosphere and oceans would be completely blasted away. This would leave our planet as nothing more than a barren rock. The explosion would also have created massive amounts of high-energetic neutrinos. These would be able to boil you from the inside out. Earth would also be shrouded in lethal levels of UV and gamma radiation. Even if you somehow managed to survive the explosion, you wouldn't last long from the harmful effects of all this radiation. You'd have damage to your eyes, skin, and even DNA. Now, if an alien species was watching this all unfold from a distant galaxy with an incredibly powerful telescope, they'd see a single bright star surrounded by an excess of reddish-colored gas. And the infrared light left behind from the explosion would be visible for a long time after. But that wouldn't be the only way all this could possibly go down. There is a possibility there could be a more peaceful alternative. Yeah, if the two stars are moving a bit slower relative to each other, they could end up merging into one massive new star as they orbit each other. Our Sun would strip mass from its smaller companion, Gliese 710, and swallow it in a process known as stellar cannibalism. Then, this extremely hot and bright star would be called a blue straggler. Though it may sound many times more peaceful, this option would still likely spell out the end of life on Earth. With our Sun now a massive blue star, the habitable zone of our solar system would be pushed further away. What else would happen if our Sun became a blue star? Well, that's a story for another What If.
The last time the world witnessed a total solar eclipse was in 2017, and its presence delighted enthusiastic skywatchers.
This is absolutely insane.
But what